Now we are going to see a lecture number 4 in the complex number, which is the module number 1 of Engineering Mathematics 1, in which we are going to deal with the expansions of cos to the power of n theta and sine to the power of n theta in terms of cos n theta and sine n theta. The exponential form of the complex number, which can be represented as z is equal to e raised to I theta, which can be further written as in the form of cos theta plus I sine theta. And its conjugate, which is z bar, otherwise 1 upon z, can be written as e raised to minus I theta, which can be further written as in the form of cos theta minus I sine n, sine theta. So by adding these two terms, we will be getting here twice of cos theta as z plus z bar upon 2, which can be simplified further, for cos theta is equal to z plus z bar upon 2, which can be represented as in the form of exponential form, which is e raised to I theta plus e raised to minus I theta by 2. By subtracting these two terms, which is z minus z bar, which can be written as 2I sine theta, from which we can write sine theta as z minus z bar upon 2I. In the exponential form, it could be e raised to I theta minus e raised to minus I theta by 2I. So this is for the simple complex number that we have written it, which we'll be using in the expansion part that we will come to know in the coming part of the lectures. So now, suppose if you're having the power z to the power of n, that is, which can be written as e raised to I n theta, then which can be further simplified as cos n theta plus I sine n theta. And its conjugate, which is z bar to the power of n, otherwise 1 upon z to the power of n, can be written as e raised to minus I n theta, which is cos n theta minus I sine n theta. When we are adding the cos n theta, we will be getting here it as z to the power of n plus z bar to the power of n upon 2, and the corresponding exponential representation e raised to I n theta plus e raised to minus I n theta upon 2. Same way, when we are subtracting it, sine n theta can be written as z to the power of n minus z bar to the power of n upon 2I, and the corresponding exponential representation that you can see e raised to I n theta minus e to the power of minus I n theta upon 2I. So whatever the expansions, whatever the part which we have seen in this particular slide, we will be using in the coming slides also, means to solve the problems. So as you know, we are going to deal with the expansions. For that particular part, the Pascal's triangle is the very important concept for the binomial expansions. So right from the first order till from the 10th order of the binomial expansions, the coefficient that you can see from the Pascal's triangle. So here, this is the Pascal's triangle. So for whenever we are using the binomial expansion, that we are supposed to write down this particular part for our understanding in order to get the coefficients of the expansions. For example, in the problem number 1, we are supposed to find the expansion of cos to the power of 8 theta. So in this case, As we have seen in the first slide of this lecture, we are supposed to consider x as cos theta plus I sine theta as x, and 1 upon x as cos theta minus I sine theta. When we are adding these two things, x plus 1 upon x can be written as 2 cos theta, because the imaginary part will get cancelled when we are adding. But we need to find the expansion of cos to the power of 8 theta. For the eighth order, that we are supposed to get the coefficients from the Pascal's triangle. So the coefficients of eighth order of binomial expansion from the previous Pascal's triangle from the previous slide, we have taken it as 1, 8, 28, 56, 70, 56, 28, 8, and 1. These coefficients we are going to use when we are writing the expansion. So as you know, cos to the power of 8 theta, we are supposed to find it out. So for that, we have to take the power of 8 on both the sides of x plus 1 upon x is equal to 2 cos theta, as in this form. That is 2 cos theta the whole power 8 can be written as x plus 1 upon x the whole power 8. So in this case, the binomial expansion, the a value is x and b value is 1 upon x. And the coefficients we are having already with us, and plus sign we are having. So throughout the expansion, plus sign will be coming as x to the power of 8 plus 8 into x to the power of 7 into 1 upon x plus 28 into x to the power of 6 into 1 upon x to the power of 2 plus 56 x to the power of 5 to 1 upon x to the power of 3 plus 70 into x to the power of 4 into 1 upon x to the power of 4 plus 56 x cube into 1 upon x to the power of 5 plus 28 into x square plus into 1 upon x to the power of 6 plus 8x into 1 upon x to the power of 7 plus 1 upon x the whole power 8. Like this, we have to write down the expansion. So whenever the power of x is decreasing throughout the expansion, you can observe that the power of 1 upon x is increasing. So one particular time in the last term, that x will not be there, only 1 upon x to the power of 8 it is there. So further, we are supposed to simplify this expansion by cancelling out the denominator and the numerator terms of x. So when we are simplifying these things, we are getting here it is as x plus 1 upon x the whole power 8 can be represented as x to the power of 8 plus 8 x to the power of 6 plus 28 x to the power of 4 plus 56 x square plus 70 plus 56 1 upon x to the power of 2 plus 28 into 1 upon x the whole power 4 plus 8 into 8 into 1 upon x to the power of 6 plus 1 upon x to the power of 8, which is the last term. So like this, we have to simplify the terms. Then we are supposed to group the terms to conclude the final result, otherwise the expansion, which is when we are grouping the terms, the like power term should be brought into one particular bracket. For example, the x to the power of 8 and 1 upon x to the power of 8 should be brought into one particular part, which is nothing but means same way x to the power of 6 and 1 upon x to the power of 6 should be written in one bracket because its coefficient is 8, which is common. So that, like that, we have to group the terms. So if you are observing this expansion, the latest part, which is x plus 1 upon x the whole power 8 is equal to x to the power of 8 plus 1 upon x to the power of 8 plus 8, which is the common coefficient for x to the power of 6 and 1 upon x to the power of 6. The third term, when we are considering, the 28 is a common term, which is 28 into x to the power of 4 plus 1 upon x to the power of 4. Then further in the next term, 56 is a common coefficient, which is 56 into x square plus 1 upon x the whole square plus 70. So in this way, we have to conclude the terms in a group way. Why? Because we are going to apply the formula. We are going to find the expansion of cos to the power of 8 theta in the next step. So cos to the power of 8 theta, we can write in the form of, that is from here, we can write only cos to the power of 8 theta here. Then 1 upon 2 to the power of 8 you can write here into the first part. This particular part can be written as twice of cos 8 theta. Same way, the second term 8 into twice of cos 6 theta. Same way, you can write the next term as 28 into twice of cos 4 theta. Then plus 56 into twice of cos 2 theta plus 70. Further, we can simplify by taking 2 as a common factor, which is, further it could be simplified as in the form of cos to the power of 8 theta is equal to 1 upon 2 to the power of 7 to cos 8 theta plus 8 into cos 6 theta plus 28 into cos 4 theta plus 56 into cos 2 theta plus 35, because we have taken 2 as a common factor. So similarly, the denominator part 2 to the power of 8, it has been reduced as 2 to the power of 7. So this what is the expansion of cos to the power of 8 as far as the first problem is concerned. So we will be seeing 2 more sums in which problem number 2, we are supposed to get the expansion of sine to the power of 8 theta in terms of sine 8 theta, sine 6 theta, and so on. So in this case, as how we have done in the previous sum, the same way we are supposed to proceed. We are supposed to consider x as cos theta plus I sine theta and 1 upon x as cos theta minus I sine theta. When we are subtracting it, we are getting x minus 1 upon x is equal to 2I sine theta. But we need to get the power of 8, sine to the power of 8 theta. So take 8th power on both the sides. And before that, we are supposed to take down the coefficients for the binomial expansions of order n, 8th order, which is 1, 8, 28, 56, 70, 56, 28, 8, and 1. The expansion can be written in this form, 2I sine theta the whole power 8, which is equal to x minus 1 upon x to the power of 8. Then apply the expansion, binomial expansion. Already we are having the coefficients with us, but here x a minus b we are having. In the place of a is x, in the place of b 1 upon x. So as we know the expansion of binomial part. Alternatively, plus minus sign will be coming. It will be starting with plus. As far as this expansion is concerned. The expansion which we have seen in the previous problem, the same way we are supposed to do it here also. But plus minus, alternatively sign will be changing. Because of the terms which we are having within the bracket, which is x minus 1 upon x. So now, same way, x to the power of 8 minus will be coming. 8 into x to the power of 7 upon 1 upon x and so on. Same expansion as what we have seen in the previous sum. The same thing we are supposed to write it here. But plus minus sign will be alternatively coming because of the terms which we are having within the bracket. The same way we are supposed to simplify it. When we are simplifying, the I to the power of 8 is nothing but 1, that everybody knows that. So 2 to the power of 8 into sine to the power of 8 theta can be written as x to the power of 8 minus 8 into x to the power of 6 plus 28 x to the power of 4 minus 56 x square plus 70 minus 56 upon x square plus 28 upon x to the power of 4 minus 8 upon x to the power of 6 plus 1 upon x to the power of 8. As how we have seen in the previous sum, the same way here also we have to group the terms of the like power of x and 1 upon x, which is x to the power of 8 plus 1 upon x, the whole power 8, should be grouped together. If you are observing, the corresponding coefficients are also same. So minus 8 into x to the power of 6 plus 1 upon x raised to 6 plus 28 into x to the power of 4 plus 1 upon x raised to 4 minus 56 to x square plus 1 upon x the whole square plus 70. But we need to find the expansion of sine to the power of 8 theta. That's how we have done in the previous sum. The same way, sine to the power of 8 theta can be written as 1 upon 2 to the power of 8. And the group terms, x raised to 8 plus 1 upon x raised to 8 can be written as twice of cos 8 theta. Same way, x to the power of 6 plus 1 upon x raised to 6 can be replaced by, in the second term, minus 8 into twice of cos 6 theta. In the third term, 28 plus 2 into cos 4 theta. So if you are observing the previous case, that is this case, which can be written as twice of cos 4 theta. Same way, 56 into x square, this part, 1 upon x square, can be replaced by twice of cos 2 theta. But we have 70 that is to be written as it is, that is constant. Then from all the terms, you can take 2 and you can divide and multiply by, so divide the numerator and the denominator by 2. So when we are doing it, the expansion for sine to the power of 8 is 1 upon 2 to the power of 7 into cos 8 theta minus 8 cos 6 theta plus 28 cos 4 theta minus 56 cos 2 theta plus 35. This is the expansion of sine 8 theta. So like this, you have to conclude your answer. And always I will suggest you to box the final solution, so that will be giving good impression to you people. The third and the last problem which we are going to deal here is, we are supposed to find the expansion for the first subdivision, cos to the power of 8 theta plus sine to the power of 8 theta. The second subdivision as cos to the power of 8 theta minus I sine to the power of 8 theta. Since we know the expansion of cos to the power of 8 theta and sine to the power of 8 theta from the previous two sums, we can straight away add those answers. That is, the expansion of cos to the power of 8 theta should be written first. all the plus sign will be there, plus sine to the power of 8 theta expansion, in which the alternatively plus sign, plus and minus sign will be there. Both the terms should be added together. When we are adding, again 1 upon 2 to the power of 7 will be common to us, all the terms. When we are adding it, 2 cos 8 theta plus 28 into 2 cos 4 theta plus twice of 35 we will have. But again, divide the numerator and denominator by 2. So we are getting 1 upon 2 to the power of 6 into cos 8 theta plus 28 cos 4 theta plus 35. So the expansion for the first subdivision, simply you can write cos to the power of 8 theta plus sine to the power of 8 theta is equal to 1 upon 2 to the power of 6 into cos 8 theta plus 28 cos 4 theta plus 35. It's very simple for finding out the expansion of the second subdivision of this sum, which we are supposed to subtract. So already we know the expansion of cos to the power of 8 theta and sine to the power of 8 theta from the previous two sums. Just substitute the respective expansions in the corresponding place of the expansions. Then just subtract it. When we are subtracting it here, the cos 8 theta terms will get cancelled. Cos 4 theta term and the constant term will be getting cancelled because we are subtracting it. Only cos 6 theta term and cos 2 theta will be there in the final answer. So in this case, when we are doing it, the calculation part, 1 upon 2 to the power of 7 into twice of 8 into cos 6 theta plus twice of 56 cos 2 theta, we will have it. So further simplification, if you are doing it, 1 upon 8 into cos 6 theta plus 7 cos 2 theta will be the final answer. So the expansion of cos 8 theta minus sine to the power of 8 theta can be written as 1 upon 8 into cos 6 theta plus 7 into cos 2 theta. So this is all about your expansions of sine to the power of n theta and cos to the power of n theta in terms of cos n theta we have seen. This is that's all for this lecture, students. We'll see you in the next lecture.